Today's topic is about the generate subsets problem. We're gonna solve this problem using the backtracking pattern I explained in this video. So if you haven't watched that video, go back and watch it. So let's begin. So first of all, let's look at the problem statement. They told us to generate the subset of a certain set, or to get the power set of the set. Meaning, we have to get all the possible subsets out of this. The empty set, 1, 2, and etc. So if we look closer into this, how can we choose all the possible subsets? If we start iterating at the elements of the set, at each element we have either of two choices. Either we place the element in the set, or we choose we don't want to place it for all the elements. So if we're having n elements, we have 2 power n choices or 2 power n subsets to generate. Here I'm having 3 elements, so the total number of choices and subsets is 2 power 3, which is 8. You can see that at the first set I chose not to choose any of these elements, so it's an empty set, and at the last set I chose them all. And in between I vary my choices at picking these elements. So let's design a pattern to follow this approach and pick elements to generate all the possible subsets. Before diving into the code, the decision tree of the generate subsets problem may look like this. For example, I have 1, 2, 3 a set. So based on our decision, we may choose these choices. First, I may choose no element. So I go to this state. Then I backtrack because I have no elements to choose from. I choose 1. So I go to this state. Now, this is a solution as well as this. 1 can have also 2. I choose to join 2 with 1. So this state. I backtrack. I choose to join 3 with 1. So 1, 3. Now, I don't want to pick 1. So I go back to this state. I choose 2, right? So 2 is now a solution. With 2, I choose 2 and 3. But why I didn't pick 1 with 2? Because I already picked it here, right? So this is the only case to join 2 with 3, which was not present in these cases. Now I backtrack until reaching 3 again, and I choose it alone, because if I want to choose it with the other numbers, I may see that I may have duplicate states. So this would be the decision tree for the generate subsets problem.
So guys, as you can see, here's the problem statement to generate the subsets. And here's the corresponding code written in C++. First, we initialize a result to contain our result. I initialize it as a global variable. Then you initialize the temp variable and you call the backtrack. But what is backtrack? Backtrack, it takes nums, the start, and the temp. Start represents the starting index it will start from in the nums, which is the main array or the main set we are going to generate subsets from. And the temp is like the container we are placing our choices at each iteration. First, we add the result, whatever it is, because the empty set should be placed in the solution. We start iterating from the starting index and until the nums size. We place our choice, and then we call the recursive calls to choose from the remaining choices, which are 2 and 3 at the first case. Then we choose to undo our choice to move to the next iteration, which will be 2, and choose from. As you can see here, it's I plus 1, not start plus 1. This will ensure to remove any duplicate states we may reach. The backtracking is occurring here when we pop back the element, or we undo the choice we have did before. And that's it for the code.
So now, after seeing the code, let us simulate the example 1 to 3 on the algorithm. First, the initial code will be like this. Nums 1 to 3, the start equal to 0, and the temporary is empty. Our algorithm first adds the temporary to the result. It then starts a for loop from the starting index. It adds the first element and it calls the recursive call with I plus 1. So I here was 0, so it become 1. Then here it will first add this to the result and call another recursive call. It will add now 1 and 2. It will print it. Now it will call another recursive call. Now when it reaches this, it only prints 1 to 3 because 3 is bigger than the size of the nums, so the for loop will never iterate. By this, it backtracks to previous states. Here it also backtracks because it's an only element. Now I is 1, so it will become 2. And then it calls the next recursive call. Because I'm calling I plus 1, not start plus 1. So 1, 3 is the third solution. Now this is empty, it will never execute and it will backtrack. So now this also has finished. Now here it was 0, so it will become 1. So I call the next recursive call. So here it added 2 and it calls the next recursive call. This is a solution, so first add set. And then it calls the next call. So add this to the solution. It will backtrack. Now this is 2, it will add 3. And the algorithm is finished. So this has been the CS tutor. Thank you for watching. If you have any questions or concerns, put them down below and I'm happy to help. See you in the next video.